So probability function, we talk about probability measure, so we'll talk about probability function. So given a measurable space, a probability function with domain, this is a function that satisfies the following conditions. Okay, so we now want to extend our idea just from a measurable space to some probability space. Okay, so to do that, we have to define a certain probability function which has the domain. So what happened is that you have your, what we are saying is that you have your sample space. Let me draw it well. You have your omega, okay, and then you get some possible subsets to form a sigma algebra. Okay, remember sigma algebra is like a set of events, okay. So we are saying that there is this probability function which we are saying, let's say x, let's call it let me use p, so to show probability. So there is this probability function p, all right, which has a domain of f. So it picks f and assign numbers to them, and remember the numbers that it assigns are probabilities. Okay, so it will be between 0 and then 1. Okay, so this definition is called a probability function. So there is a probability, there's a function called p which is defined on f. It picks elements in f and gives them some number within 0 and 1. Okay, all right, so that's the definition of the probability function. So remember that always the empty set is an impossible event, so the value is a 0, and then the probability of the sample space is a sure event or a certain event, so that is a 1. And remember that probabilities are finite. Okay, probabilities are positives, they are not negative, so it should be greater than 0. And then if you have, look, if you pick any element, that's what I'm saying, if you pick any element in f, the sigma algebra, remember sigma algebras are events, a collection of subsets. Okay, so if the example we gave above, your sigma algebra contains the empty set, all right, the empty set, the set itself, 1, all right, you contain another set, let's say 2, all right, and then in that order. Okay, that order contains a lot of stuff. Now if you pick any element in this sigma algebra, its probability should lie between 0 and 1, so which is defined by this function. So the p, which is a probability function, is saying that okay, I pick some element in that and I assign an element between 0 and 1. Okay, that is what it is. All right, so take note of that. So this is a very interesting fact, so make sure you go through that. So countable additive, that is if you have a1, a2, so if you have a lot of events in a sigma algebra, okay, a lot of events in the sigma algebra, okay, and then they are piecewise disjoint, that means if you pick a1 and then a2, you find an intersection and there's nothing happening, you get a null set. If you pick a2 and a3, or there is a null set, okay, then you can say that the probability of the union is going to be the sum of the individual probabilities. Okay, so take note. This is a very powerful tool, so take note of that. So what we are saying is that let me show an illustration. Let's say f is this. Okay, f is having an empty set, but it is having the set itself. It is having another set, let's say 2 and 3, and then it is having a, let's say, a 1. Now if I pick this set, a 1 as my a1, then I pick this as my a2, pick this as my A2. Okay, so I look at A1 and A2. If I take the intersection of this and this is going to give me a null set. So intersection of A1 intersection A2, all right, is actually equal to empty set. Okay, so the fact that A1 and A2 are the intersection is empty set, to say that this A1 and A2 are what? Piecewise disjoint. Okay, they are disjoints, they don't have anything in common. So if you have a lot of that, I pick another one. Let's say A3. Let me pick A3 as this. So let's say this is A3. Alright, this is A3. So this is A3, and I pair them. So when I pair A1 intersection A3, alright, I still get empty sets. Intersection is still empty sets. Alright, so A1 and A3 are also piecewise disjoint. Okay, so when you have a lot of them, A1, A2, A3 up to AN, and then all of them are piecewise disjoint, then you want to find the probability of the union. We are saying that it's just the sum of the individual probabilities. Okay, so you sum A1, probability of A1 plus probability of A2 plus probability of A3 in that order. Remember that this is a probability function. Remember, it only gives a value, it picks a value from the sigma algebra and assign a number within 0 and 1. So now we are here, probability model. Okay, so we've gone through how you can get a probability model, and then this is what we ended at. Okay, so the triple this is called a probability space, or the probability model you want. Okay, so remember that when you are performing an experiment, you have a sample space, and then you generate a sigma algebra using the sample space. Then you try to give the element some probability measure, and then give the event that is happening in the sample the sigma algebra to some probability measure p. All right, now when you put this together, now your model is ready. We call this the probability model. Now you are in a probability space. Okay, probability space. Okay, probability space. So now you can use your model by computing probabilities, because you have all the information you need. You have your sample space, and then you'll be able to send some give them some measure, some probability measure, so you are good to go. All right. Right, so the next thing to talk about is a conditional probability. Okay, conditional probability. So the conditional probability is something that is very interesting. Okay, so given that some event has happened, what is the probability that some other event will happen? Okay, that is what it means to say there is a conditional probability. Okay, so if you look at this, we are looking at the probability that A will happen given that B had already occurred. Okay, so B happened, and then we are looking at the effect B will have on A. So we are saying that, okay, if B has happened, what's the probability that A will happen? And that is giving us the intersection of A and B. If only they are not disjoint, so there will be an intersection, and then the probability of what over probability of B. So make sure that probability of B is not going to be equal to 0, because it will make this function or this formula undefined. Okay, so this is a typical example. Mary has 3 children. One is a boy. What's the probability that the other child is a girl? Okay, so if you have Mary have 2 children. Okay, 2 children. So one is a boy. What's the probability that the other child is a girl? Okay, so let's go through that, and you see the essence of conditional probability. So you see that you see that the condition, what they have been giving to you is the fact that one is a boy. So that's a clue. That's like a probability that one is a boy. There is one person is a boy. Okay, one is a boy. So that is like a B. This is the information they've given you. This is like a B. What they're giving you, and what they want you to know is that what's the probability that the other child is a girl. So the other child is a girl. The other child is a girl. So what's the probability that the other child is a girl? So other child being a girl, alright, is A. Alright. So giving you the information that one is a boy, what's the probability that the other child will be a girl? So that's wrong. So you have to first know your sample space. Every time you know your sample space. So your sample space is that, hey, it can happen that marriage children can be boy, or a boy, a girl, or a boy, or a girl. So it can be that the firstborn is a boy, the secondborn is a boy, the firstborn is a boy, the second one is a girl, the first is a girl, and then a boy or a girl, right, together. So the B, which is given, one is a boy. So if one is a boy, then the only outcome you can get is this, that, okay, and then this. There is one is a boy. So this at least one is a boy here, one is a boy here, one is a boy here. All right. So now so girl, all right. So the other one being a girl is also this this one, that one. There's a girl, right? So you have to find the intersection of this and that. The intersection of this and that. So what's the intersection of this and that? This one and this one. So the intersection, when you find the intersection, you will get only two items. You get boy, girl, and then girl, boy, isn't it? So there are two items in this. So if this is called A, remember from the probability function or the probability measure, we said that if A is an event which is coming from a certain sigma or a certain sample space, and then the probability measure on the points on each of them is given. So here all the probability measures are 1 over 4, 1 over 4. So if I want to find the probability of A, is 1 over 4 plus 1 over 4, which is given on top. Alright. And then probability of B, there are three items inside, isn't it? So 1 over 4 plus 1 over 4 plus 1 over 4, and that is that. Simplifying that will give you a conditional probability. Right. So these are examples on the conditional probabilities. Okay, so go through.